Hello everyone, my name's Adam and welcome back to the channel. Today we're taking a look at the Elegoo Mars, an MSLA resin printer from Elegoo, a tech company based in Shenzhen, China. Just a quick note before we go any further, I am quite new to resin printing, so just bear that in mind when I give you my opinions and thoughts. If like me you're just getting started with MSLA or any other types of resin printing, then check out the video linked in the description, which will give you a list of stuff that you'll probably want to get if this is something you're going to be taking seriously. In fact, a lot of it you're going to need just if you want to use it at all. The Elegoo Mars is an MSLA resin printer. It cures resin in a vat, layer by layer, by shining a high-power UV light through an LCD screen. This LCD screen creates a mask. The mask blocks the UV from passing through to the resin in certain areas. In the areas where UV light can pass through, it gets to the resin, which hardens and cures. The 5.4-inch LCD screen is 2560 by 1440 resolution, giving an XY precision of 47 microns and a build area of 120 by 68 millimeters. The lead screw driven Z-axis gives you 155 millimeters of Z travel and typical layer heights of 50 microns, although a range of layer heights is possible. Included in the box is some nitrile gloves, a plastic measuring cup, which is now broken and disposed of, surgical face masks, paint filters, 3D printed drip assist tool thing, resin tank with an FEP film, detachable build plate, plastic scraper, 60 watt power adapter, a USB drive, the user manual, and a small toolkit with some Allen keys and spare screws. For all the prints I made in this review, I used Chi Box slicing software. So when you get the printer out the box, the first thing you need to do is assemble it, which fortunately is very easy. You simply take the vat with a pre-applied FEP film, slide that over the LCD screen and use the two knobs to tighten it down. You place the build plate assembly onto the Z carriage and tighten that down very lightly, well, firmly, and then you place the cover over the top. Of course, if you're going to print something, you do need to remove the cover and fill the vat with resin. Well, not fill, but place resin into the vat. Before starting a print, you will also need to level the bed and make sure it's secure, and we'll cover that in just a moment. So the assembly process is very simple and very difficult to get wrong. Let's move on to the design quality, build quality, and stiffness. The Mars is a very basic machine. Like many resin printers, there's not very many moving parts. You literally have the Z-axis and a cooling fan. However, because of the high precision that it can achieve, any movement or lack of stiffness in the components in key places can result in a poor print quality. The Z motor, which drives all the vertical movement of the printer, is mounted to a soft rubber damper, which is good in some regards. It reduces the noise, but because of its softness, it probably is having an effect on the overall quality of the print, especially in the first few layers, where I'm seeing some of these Z layers actually disappear. To clarify, these layers aren't actually disappearing. They are being printed. They're just being printed kind of directly on top of each other because of the compression. They're all just basically being printed in the same place. This big red cover over the top is made of acrylic and is fairly sturdy, but the seam up the back where it's been folded is a little bit vulnerable, and even if you handle it carefully, is probably going to break at least a little bit. You can probably super glue it back together though. What would be great is to have a handle or something on this case, so not only do you get one-handed operation, it also just means you won't get finger marks all over the case like I have. The UV light source in this machine is a point source right down in the base. So that means all the light is coming from one point, which means the distance to the bed varies depending on the point on the bed. There are some reflective panels around that light to help kind of balance that out and try and get the best amount of light onto the surface possible. However, having this point light source does mean that the lighting is not consistent across the build platform, which will have a negative impact on the printing results. I've not necessarily found a measurable problem with this, but I expect with larger prints or with printing in certain areas at certain sizes, you are going to have some slight degradation in either quality or integrity of the print. The control board that drives all of this is a small ARM-based control board. It has a single axis, which is for Z, plus fan and LED controls, and that's pretty much it. There's a little header on the board labelled Wi-Fi that looks like it would accept a small little Wi-Fi board, but I'm not certain that you can actually use that Wi-Fi in a way that would help your printing process. However, if the community find a way that it does work, that would be quite cool. Durability and longevity. As I'm a part of the Elegoo Mars Facebook group, I do from time to time see new users getting started, and those new users sometimes have problems. Now, I didn't have any problems myself, which is why I'm not going to force this on too heavily, but there does seem to be a repeated pattern of either the LCD having a lot of dead pixels, meaning areas just can't light up, or the LCD is just not plugged in quite correctly, meaning it just doesn't really work. It just goes all over the place, so you get glitches like halfway through the print. Fortunately, I didn't have any of those issues though. There have also been additional reports of the LCD lasting only around 100 hours. I'm at around that point now, actually probably a little bit over, and I've not had any problems yet, which I'm pleased to report. The LCD is not covered under the warranty because it is seen as a consumable part. The LCD will break down because of the high power UV shining through it. However, Elegoo do seem to be reasonably good at replacing these regardless of that warranty. So, I mean, I've not had to replace mine yet, so I'm looking pretty good so far. Electrical safety. Unlike many low-cost FDM printers, resin printers are really very simple. There's only one moving axis and there's no heaters. I mean, the UV produces a fair bit of heat, but it's not like the high power heaters you have on heated beds and extruders. As a result, the electrical safety is generally much easier to take care of. In the case of the Elegoo Mars, there's no mains power to deal with at all. There's an external power brick, which powers the whole machine, and it just delivers DC into the unit. So even if you take it apart, there's still only DC there. The power brick does seem to be just about adequate for the requirements of the machine. It does get a little bit warm, but there's definitely doesn't seem to be any points where it's actually failing, so it seems just about right. However good the electronics are though, it doesn't make this printer safe for children. Let's move on to resin safety. Being a toxic substance, there's a lot to consider when using UV resins. Even those that don't smell that much have no substantial evidence to prove that the less smell is less harmful. So personally, I would treat every resin as if they're equally harmful and can be very damaging. For this reason, I'm very dissatisfied with the included face mask. This is a surgical face mask. It's designed to capture one's breath as it exits your mouth, capturing any moisture and bacteria that may be contained in your breath. In fact, certainly are contained in your breath. This type of mask is not suitable and provides no protection from volatile organic compounds which come from resins. When I asked Elegoo about this directly, they said that the inclusion of the face mask was as protection from the face in the instance of splashing rather than to protect you from the fumes. Personally, I feel that the inclusion of this item in the box suggests that it's suitable for working with the printer and that this will protect you from that. However, it's just not the case. I'll leave a link in the description to a face mask with filters that is suitable for using with volatile organic compounds. I use one and it totally removes the VOCs in the air by using an activated carbon filter. There is no activated carbon filter in this face mask. On the good side though, the gloves that are included are the right thing and there's enough of them there to last you a few prints. They are disposable gloves, so you will need quite a lot of them though. In fact, if you're going to be using the printer quite a lot, you're going to need to buy a whole lot more. The last key safety item is either glasses or goggles to protect your eyes. None of these are included, which I wouldn't necessarily expect, but make sure that you do get some. I'll leave, again, links in the description, or you can check out my video with an equipment list that includes key safety items for using with resin printers. As the problematic substance here is volatile organic compounds and they can't be filtered with a basic filter, you need an activated carbon filter. It would be good if one was included in the printer, so that for those long prints where it's generating and mixing and kind of swirling around and releasing a lot of fumes, that there was something on the printer that would pass all the internal air through that filter and then only send out clean air. So just to summarize the safety thing, personally, I think it would be better to have more hazard notice during the unboxing experience, the purchasing online, to make sure users are fully aware of the dangers of the substances they're dealing with. Including a mask like this is not a good sign that they care about the safety of their users. On a side note, I really look forward to a future where we can have much safer resins and we don't have to deal with all the kind of waste disposal problems and safety issues that we have with the current solution. I really don't think this stage is really very suitable for consumers. Reliability and consistency. Reliability is definitely one of the more difficult issues for me to review here, because when I do get a failure, I'm not totally sure if it's me that's messed it up or if it's the printer that's messed it up, because I'm just not that experienced. However, as I went along, I did learn quite a few things. A large majority of the prints that I started did also finish, which is good, but on the instances where I had multiple parts on the plate, there tended to be some failures out of that whole set. Overall, there seemed to be a little bit of an ebb and flow, so I'd have a situation where I'd print a print and it would go really well, I'd print multiples in a row and it'd be absolutely fine. I'd then change to something else and I'd get a good one, then a bad one, a bad one, a bad one, and then a good one. So it just seemed to kind of up and down a bit. So reliability was maybe a little bit hit and miss, but generally still I was very happy with the consistency that it did get once I got the settings right for a particular print. For example, I did go through a particular spurt of printing a single 5-hour print time after time after time after time, and it did succeed every single one. They all looked identical, so reliability and consistency, when you get it right, is actually pretty good. Let's move on to noise. As there are only 2 moving components in the printer, you wouldn't expect it to be very noisy. Nevertheless, it tries as hard as possible to be as noisy as it can. Okay, it's actually not that bad. It's not that noisy. The noisy part is the fan. The cooling fan that cools the UV light is a little bit louder than I would like. You could probably aid this by maybe having some softer feet, but generally because it's quite a consistent hum, it's not really too disturbing. For example, I've had it running overnight where I've been sleeping in the next room, and it's been churning away and it makes a little hum, but it's not really that noticeable. I suppose the difference is with an FDM machine, if you get noise there, it's generally like as it's moving fast and then it's doing it's just, with FDM machine, your tones and pitches and speeds are going all over the place, whereas this low hum is not too disturbing. The damper on the motor definitely contributes to this fairly low noise, but again, it's impacting the rigidity and quality of the printer, so up to you whether you think that's worth it. Let's move on now to general ease of use and usability. First of all, the USB port, which you need to plug the USB drive into to start any print, is located on the back. If that doesn't suggest that they never really used the printer before selling it, then I don't know what does. But a quick extension cable will make it really easy to access, and they're not very expensive. The touchscreen is pressure sensitive, so resistive rather than capacitive. So unlike your smartphone, presumably you have one, which is very easy, as soon as you touch it, it senses it. This, it needs a little bit of pressure to be applied in order for it to trigger. Is that perfect? No, but is it adequate on a very low cost machine? I'd say absolutely yes. I wouldn't want to necessarily pay more for a capacitive screen. Firstly, you don't really use it very much. All you need to do is to be able to start a print and maybe change a couple of settings as quick as possible. And because the software is responsive, and although it requires some resistance, the screen is still responsive, I think it's absolutely fine. And it does also mean you can use a pen or something to touch it instead of having to use your finger. I think that works pretty well. The plastic scraper that's included is basically garbage, so you might as well just get rid of it. It really doesn't help in any way. I generally use a small metallic kind of crafting palette knife, which is very thin, for getting prints off and doing anything like that. It's just much finer tool for fine work, which you'll be doing here. Now let's get into the printing process. But before we do, don't forget to like and subscribe if you've enjoyed the video so far. Printing setup. Leveling the plate is sort of manual but sort of automatic. There are grub screws in the mount that holds the plate. You just loosen those off, home the printer, retighten them. We're obviously making the build plate kind of square. Retighten the grub screws and then you're pretty much done. It's really very easy to do and very difficult to do wrong. There is no real guarantee that the build plate itself is really very flat, but I have not got any significant evidence to suggest that it isn't, so I'm pretty happy with how flat it is. Slicer setup, also very easy. In fact, so easy that I've basically forgotten all the process. It was really just like install the software, select Elegoo Mars, and it was done. It was so easy that I've literally forgotten it. Printing quality. The print quality is generally very good. This Eiffel Tower, for example, is absolutely stunning. I almost can't believe that you can 3D print stuff like this. It's absolutely mental. The high precision of the machine is obviously a really major selling point, being able to do details of down to 47 microns. However, the dimensional accuracy that I've found so far is generally actually not quite as good. The Z-axis has the biggest problem because it's losing a couple of layers in the first kind of part of the bed, which if your print is mounted to the bed, then that's going to affect. And even the XY accuracy doesn't seem to be as good as even some of my FDM machines. Not totally sure why. Again, not very experienced in using MSLA machines, but just so you know, precision, high, accuracy, it's not bad, but it's not as good as you might expect with 47 microns of precision. One of the downsides of when you're resin printing like this, as you create a layer, you're actually sticking it to the FEP film at the bottom as well as to the print or build plate, which means it's being stuck between two surfaces. Between each kind of layer creation, you have to peel that off and then come back down with a slight gap to create a new layer. The high film forces, which you get from peeling it off, do tend to be quite problematic, and thus you need a lot of support material to hold everything together. Not only that, but because your layers are so fine, they have really no way to support themselves unless there's stuff below it. So again, lots and lots of support material required, and this is one of the things that I found quite challenging to get exactly right. Not only that, but there's kind of a limit to how close you can put your support kind of struts. You can't do a whole kind of zone like you can in FDM. It's literally just like points onto the print and you just stick them all over the place. But because you can't put them too close together and the sensitivity in such high precision is really high, even those very small gaps between those supported areas tend to just droop. So it's a weird situation where you have this potential for very high precision, but even the very tiniest problem is really, really obvious because of that, how good the rest of the print looks. From time to time, a print will finish, but none of it will be stuck to the build plate. You do get this mildly amusing moment where you see the chirpy "print is finished" message on the screen, and then it's just like displaying this, nothing's there. Unfortunately, then you realize that that means it's stuck to the FEP film, which means you've got a whole lot of work ahead of you to remove that dead print, basically, from the film, which involves removing all the liquid from the vat, pouring it out, probably filtering it, maybe putting it back in the container, where you then clean that, take the kind of old discarded print off, put everything back in, and it just becomes a whole palaver and mess. So yeah, not a whole lot of fun when it sticks to the film instead of the bed. Unlike FDM machines, there isn't the same broad range of bed surfaces. I mean, this one, I guess you kind of had two. You've got the FEP film, which is the kind of more advanced material surface, and then you've got the plain aluminium bed at the top. The aluminium bed is powder coated and it's reasonably durable, but do be careful if you are using metallic tools on it because you don't really want to scratch it. If you do, you've probably got a whole lot more work ahead of you to then basically remove the whole top surface to make sure it's perfectly flat again. And yeah, that's going to be a lot of work. Since there is absolutely no flex in the aluminium bed, you do need a method for removing the prints, and this generally is using a craft palette knife under the corner of the raft, which generally has some nice 45-degree angles on it for removing prints. At this stage, everything is a little bit soft, so it's not too difficult, but because of the way that it's attached, there is a kind of vacuum between the part and the bed, so it holds very stiffly. Just be very careful, skim all the way around the edges, and then just slowly pry it away, and I'm sure it'll come off just fine. Special features. The Elegoo Mars is quite slim on special features. I suppose for this price point, you're not necessarily expecting a lot of special, you just want the basics to be done right. I suppose in reality, the most special thing about this print is the very simple bed leveling system, which from what I've seen online of older machines, this is a very simplistic and simple way to do it. So I'm pleased that they've gone with this very kind of assisted automatic method. Is it automatic? Kind of. Is it manual? Kind of. Is it easy? Definitely yes. It works really well, but make sure that the first time you undo your grub screws that your hand is between the plate and the bed, or you just remove the plate, because in some instances, due to quality and assembly issues, it doesn't work quite right and the whole thing just falls out, and you don't want it falling on your LCD screen. So what's my overall summary and recommendations? Overall, I think it is a great printer. It does print with excellent quality, excellent resolution. You get amazing, like very simple things to super complex shapes that you really couldn't make in any other method. and is honestly just a phenomenal piece of kit for doing very fine detail. I wouldn't necessarily recommend it for mechanical parts. I mean, even basic resins like this, mechanically not that great. They're very brittle, quite fragile. But for doing aesthetic things where maybe scale, they don't need to be very large, the quality you can get is really exceptional. The reliability is also definitely acceptable. However, in my opinion, there are still some serious safety concerns which I'm really not happy about. The community in general does seem to understand that there are volatile compounds involved, and you need to be careful when dealing with them. You need the proper safety equipment to use them. Elegoo just needs to have some more notification to users about what safety equipment is required, and not include rubbish like this, implying that this is good enough to protect you from the fumes. I would not recommend this machine in any circumstances for those at schools, or with children, or with pets. The compounds, chemicals involved are just not safe enough to be using in those situations. The printer itself, yes, it's absolutely fine for those situations. But the resins, absolutely no. I would not recommend it at all. The printer as a whole though, for those in the right situation where you can safely and securely use it without any risk of damage to yourself and others, it is a really good printer and I would definitely recommend it. The price is very good and the capability is also very good. However, there is quite a lot of additional equipment that you will need, as I've mentioned previously during this review. And of course, there'll be a link in the description for a video I created with a list of stuff that you're probably going to want if you're going to be getting involved with 3D resin printing. That's pretty much all from me today on my Elegoo Mars 3D printer review. Thank you very much for watching and I will see you in the next one.